Today we are going to discuss the preparation methods of alcohol and phenols. So let's read from the book, The Preparation of Alcohol. Alcohols are prepared by the following methods. First method is from alkene. By acid catalyzed hydration. Alkenes react with water in presence of acid as a catalyst to form alcohol. In case of unsymmetric alkene, the addition of reaction takes place according to the Markovnikov rule. Here let's examine the reaction. In this reaction, carbon-carbon double bond is there, means there is alkene. When it reacts with water in presence of H+, means acid catalyst. Water get attached to the double bond and here you will get alcohol. The addition of water takes place according to Markovnikov rule. Means negative part of the reagent goes to the carbon that has less number of hydrogen. Propene is the example of unsymmetric alkene. So here this is propene. This is unsymmetric alkene. So when the addition of water takes place to the unsymmetric alkene takes place according to the Markovnikov rule. Means negative part of the reagent. In water, negative part is OH negative ion and positive part is H plus ion. So negative part means OH negative goes to the carbon which is bonded to less number of hydrogen. So here when you see this sp2 hybridized carbon has just one hydrogen and another carbon is bonded to 2 hydrogen. So OH negative will get attached to the carbon which is bonded to less number of hydrogen. So that's why OH get attached to the second carbon. And here H plus will get attached to the first carbon and you get propane 2-ol. So this is propane 2-ol. Now there is a mechanism of this reaction. So let's examine the mechanism. The mechanism of reaction involves the following 3 steps. In first step, protonation of alkene to form carbocation by electrophilic attack of H3O plus ion. As here we have taken acidic medium. So when water react with H plus, it will form H3O plus ion. This H3O plus ion act as an electrophile. So this will act as an electrophile. In the first step, so when alkene react with H3O plus ion, one of the carbon utilizes both the pi electrons to make bond with the H plus ion. The another carbon will develop positive charge and water is released in the form of byproduct. So in this first step, formation of carbocation takes place. So this is the carbocation. So this is the first step in which carbocation is formed. In the second step, nucleophilic attack of water on carbocation. Now this water which has lone pair of electron act as a nucleophile. So it will act as a nucleophile. So when it attack on formed carbocation, here you can see water donated lone pair to the carbocation. That's why oxygen has developed positive charge. So in the third step, deprotonation takes place. So water removes H plus ion from this cation and as a result of it, alcohol is formed and H3O plus ion is regenerated. As the H3O plus ion is regenerated, which is used in the first step, it is a catalyst. Now come to the second method. By hydroboration oxidation. Diborane BH3 whole twice reacts with alkene to give trialkyl borane as addition product. This is oxidized to alcohol by hydrogen peroxide in presence of aqueous sodium hydroxide. So let's examine the reaction given here. So the reaction is with propene. This is propene when it reacts with diborane. You know, boron is electron deficient species. So when diborane react with propene, as the boron is electron deficient, carbon utilizes both the pi electrons to make bond with the electron deficient boron. So it will make bond with the electron deficient boron. As it make bond with the electron deficient boron, another carbon will develop positive charge. So here the second carbon. So I will explain it here also. So this is CH3 single bond CH double bond CH2 when it react with diborane. So if I take the example of borane, that will be easier for me to explain the mechanism. So this is BH3. As you know, boron is electron deficient species. So here one of the carbon utilizes both the pi electrons to make bond with the boron. And H is released in the form of H negative ion. So here you will get the product CH3 single bond CH single bond CH2, and as it has make bond with the boron, so here you will get BH2, and this carbon will develop positive charge. Now the H negative ion will get attached to this formed carbocation. Now H negative ion will get attached to the formed carbocation. So it will get attached to the formed carbocation, and here you will get CH3 CH2 CH2, and it is bonded to BH2. Now this is monoalkyl borane. So this is monoalkyl borane. Now this monoalkyl borane react with another molecule of alkene. So now this monoalkyl borane react with another molecule of propene. So here this is CH3 single bond CH double bond CH2. So again one of the carbon utilizes both the pi electrons to make bond with the boron, and another H will be removed in the form of H negative ion, which get attached to the formed carbocation. So boron will get attached to the first carbon, and hydrogen, which is released in the form of H negative ion, will get attached to the second carbon. So here again you will get the structure CH3 single bond CH2 single bond CH2 whole twice, and it is bonded to BH. Now this is the dialkyl borane. So this is dialkyl borane. Now this dialkyl borane react with another molecule of propene. So here this is CH3 CH double bond CH2. Now again one of the carbon utilizes both the pi electrons to make bond with the boron. So it will make bond with the boron, and this H will be removed in the form of H negative ion, which will get attached to the second carbon. So this time you will get trialkyl borane. So here you will get CH3 single bond CH2 single bond CH2 whole thrice boron. So this is trialkyl borane. Now this trialkyl borane undergo oxidation in presence of H2O2 hydrogen peroxide and aqueous NaOH, means NaOH and water molecule. So by the oxidation you will get CH3 CH2 CH2, and it will convert into OH, and here you will get BOH whole thrice. Now let's read from the book. The addition of borane to double bond takes place in such a manner that boron atom gets attached to sp2 hybridized carbon carrying greater number of hydrogen atoms. The alcohol so formed looks as it has been formed by the addition of water to the alkene in a way opposite to the Markovnikov rule. In this reaction, alcohol is obtained is an excellent yield. Now let's try to understand the meaning of these lines. So if I ask you to add water molecule to propene. So this is CH3 single bond CH double bond CH2. When you add water in presence of H plus ions, means in acidic medium, when you add water to propene, OH will go to the carbon which is bonded to less number of hydrogen. So that's why here you will get CH3 single bond CH single bond CH3 and OH will get attached to the second carbon. And this addition of water takes place according to Markovnikov rule. So the product is formed according to Markovnikov rule. But when you see the product of hydroboration oxidation, here when you see CH3 single bond CH double bond CH2, when it undergo hydroboration oxidation, means when it react with BH3 whole twice in presence of H2O2 and NaOH and water, you will get CH3 CH2 CH2OH. So when you see the product of this reaction, here OH get attached to the carbon which is bonded to more number of hydrogen. So this product seems to be formed according to anti-Markovnikov rule. So why does it seems to be formed according to anti-Markovnikov rule? Actually the reaction takes place according to Markovnikov rule, but the product seems to be formed according to anti-Markovnikov rule. So why it is so? Here OH negative replaces boron, and boron is electron deficient, means it acts as an electrophile. According to Markovnikov rule, electrophile get attached to the carbon that is bonded to more number of hydrogen. That's why in the end product, OH get attached to the carbon which is bonded to more number of hydrogen. But OH negative, here OH negative is not an nucleophile. It just replaces the electrophile. That's why the end product seems to be formed according to anti-Markovnikov rule. Now come to the second method. And let's read from the book. Second method is from carbonyl compounds. And the first method is by the reduction of aldehyde and ketones. Aldehyde and ketones are reduced to the corresponding alcohol by addition of hydrogen in presence of catalyst, catalytic hydrogenation. The usual catalyst is finely divided metal such as platinum, palladium or nickel. It is also prepared by treating aldehyde and ketones with sodium hydroborate, NaBH4, or lithium aluminium hydride, LiAlH4. Aldehydes yield primary alcohol, whereas ketone gives secondary alcohol. So let's examine the reaction given here. Here RCHO, this is an aldehyde. When aldehyde undergo catalytic hydrogenation, so addition of hydrogen in presence of metal catalyst, here palladium is given. As it is an aldehyde, it results in the formation of primary alcohol. In the second example, here there is ketone. When ketone undergo catalytic hydrogenation, here the reagent is given NaBH4, which is sodium borohydride. It results in the formation of secondary alcohol. So whenever aldehyde reduces, it reduces to primary alcohol, and when ketone reduces, it reduces to secondary alcohol. Now come to the second method, by reduction of carboxylic acid and esters. Carboxylic acids are reduced to primary alcohol in excellent yield with lithium aluminium hydride, a strong reducing agent. So when carboxylic acid reduces with lithium aluminium hydride followed by the hydrolysis, it results in the formation of primary alcohol. However, lithium aluminium hydride is an expensive reagent, therefore used for preparing special chemicals only. For the commercial method, we do not use lithium aluminium hydride as it is an expensive reagent. For commercial method, acids are reduced to alcohol by converting them to ester, followed by their reduction using hydrogen in presence of catalyst, catalytic hydrogenation. So if you want to prepare alcohol commercially, it is always advised to convert acid first into ester, then by catalytic hydrogenation you can convert it into primary alcohol. So here this is an acid. So when acid react with alcohol, you will get ester. So this is an ester, and now the formed ester undergo catalytic hydrogenation, and here you will get primary alcohol. So this is the cheaper way to produce primary alcohol by using acid. Now come to the third method. The third method is from Grignard reagent. The alcohols are produced by the reaction of Grignard reagent with aldehyde and ketones. The first step of reaction is the nucleophilic addition of Grignard reagent to the carbonyl group to form an adduct. Hydrolysis of the adduct yield an alcohol. So let's try to understand how this reaction takes place. So let's try to understand the generalized reaction with carbonyl group. So this is the carbonyl group, and there are two free valencies. They can be bonded to hydrogen or the other alkyl group when it reacts with RMgX. So this is RMgX. This RMgX is an organometallic compound. There is a electronegativity difference between carbon of alkyl group and magnesium. Magnesium is electropositive element, so that it will develop delta positive charge and alkyl group will develop delta negative charge. Here also there is a dipole moment towards oxygen. So oxygen is delta negative and carbon is delta positive. So that's why this alkyl group, which is negatively charged, will attack over electropositive carbon, and the pi bond moves to oxygen. Now you will get the adduct. So here this is carbon which is bonded to two other bonds, and here alkyl group will get attached to the carbon, electropositive carbon, and the oxygen will get attached to the magnesium. So here it will get attached to MgX. Now this is the adduct. This adduct when undergo hydrolysis. So when it undergo hydrolysis, this bond will break and OH negative will go towards the electropositive metal and H plus will go towards the electronegative oxygen. So as a result of it, you will get carbon. There are two free valencies. This is alkyl group and this is oxygen which get attached to the hydrogen. And here you will get OH. And you will get the byproduct Mg. One side it will attach to OH negative ion and on the other side halogen will be there. So this is the byproduct and this is the main product. So that's how you can prepare alcohol by the reaction of RMgX with carbonyl compound. Let's try to write the reaction with formaldehyde. So if I take the example of formaldehyde, so this is HC double bond OH. When it react with RMgX, this is RMgX. So as we discussed earlier, magnesium is electropositive element, so alkyl group will become delta negative. And here oxygen is delta negative, so carbon will be delta positive. So alkyl group will get attached to the electropositive carbon and pi bond will move over oxygen. So as a result of it, you will get H, C, H. Alkyl group will get attached to the carbon and here oxygen which will make bond with the magnesium and halogen. And after the hydrolysis, this bond will break. OH will go on the side of magnesium and H plus will go towards the oxygen. So as a result of it, you will get CH2R CH2OH. So this is the primary alcohol. Now let's take the example of ethanol. So here this is carbonyl group. One side it is bonded to CH3 and on the other side it is bonded to hydrogen. When it react with RMgX. So R will get attached to the carbon and Mg will get attached to the oxygen. So here you will get CH3 carbon. One side it is already bonded to hydrogen and one side it will make bond with the alkyl group. It is bonded to oxygen which is again bonded to MgX. And after the hydrolysis you will get CH3 CHR and here OH. So this is the carbon to which OH is bonded to another two carbons, means this is the secondary alcohol. So when RMgX react with the formaldehyde, so this is formaldehyde. When RMgX react with the formaldehyde, it results in the formation of primary alcohol, while the another aldehyde result in the formation of secondary alcohol. Now come to the ketones. So if I take the example of ketone, so here I can take acetone. This is CH3 C double bond O. It is again bonded to CH3. So this is acetone, which is a ketone. When it react with RMgX. So in the same way, this is CH3 whole twice C O MgX and this carbon will get attached to the alkyl group. After the hydrolysis, here you will get CH3 CR. If I expand it for your convenience, here OH and here you will get the byproduct MgOH and here it is bonded to X. So when you see the carbon to which OH is bonded, this carbon is bonded to another three carbons. So that's why the formed alcohol is tertiary alcohol. Means when ketone react with RMgX, it results in the formation of tertiary alcohol. While any other aldehyde, when it reacts with RMgX, it results in the formation of secondary alcohol. Only formaldehyde gives the primary alcohol on reacting with RMgX. Now here, let's read from the book. You will notice that the reaction produces primary alcohol with methanol, secondary alcohol with other aldehydes and tertiary alcohols with ketones. Now let's try to solve this example. Give the structure and IUPAC name of the product expected from the following reaction. The catalytic reduction of butanol. So this is the first question. First of all, draw the structure of butanol. Butanol means there are 4 carbons. So CH3, CH2, CH2 and this is aldehyde functional group. So this is butanol. When it undergo catalytic hydrogenation, so here H2 in presence of PD, here you will get CH3, CH2, 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 OH. So this is the structure of butanol. Now come to the second question. Hydration of propene in presence of dilute sulfuric acid. Means here you have to add water molecule to propene in acidic medium. So when you add water molecule to propene, first of all draw the structure of propene. This is CH3 single bond CH double bond CH2 when you add water in presence of acid. So here H plus ion. So this addition of water takes place according to MK rule that we just have discussed. So here you will get the product CH3 single bond CH single bond CH3. OH will get attached to the middle carbon. So here you will get propane 2 all. Now come to the third question. The reaction of propanone with methyl magnesium bromide followed by hydrolysis. So here you have to write the reaction with propanone. So first of all draw the structure of propanone. Propanone means acetone. So this is CH3 single bond C double bond O single bond CH3. When it reacts with methyl magnesium bromide, means here alkyl group is methyl CH3 single bond Mg, it is bonded to Br. And as we have discussed before, the magnesium will be electropositive. So the carbon attached to magnesium will become electronegative. And here this carbon is electropositive and oxygen is electronegative. So this alkyl group will get attached to the carbon. Here you will get the adduct carbon which is already bonded to 2CH3. It will get attached to this alkyl group which is methyl CH3. And here oxygen will make bond with the MgBr. After hydrolysis, so this bond will break, OH will go towards magnesium and H plus will go towards oxygen. So the product that you will get will be carbon. It is bonded to 3 sides with the methyl. So here CH3, CH3 and here you will get OH. Now name this molecule. First of all select the longest carbon chain to which functional group is bonded. So here this is 3 carbon long chain to the OH group is bonded. And there is one substituent. Substituent is of methyl. When you number the chain 1, 2, 3. Methyl is bonded to second carbon. So here you will write 2-methyl. Parent is 3 carbon long. So the parent name will be propane. OH is bonded to second carbon. So here you will write 2 all. In the next video, we will discuss the preparations of phenol.